Come back to the next rule of the coordination compounds, how to name. Let us see this. 1 minute, please. So the fourth point is when more than one type of ligands are present, they are named in a alphabetical order. In this example, within a square bracket of the coordination entity, central metal atom, I've written CO and Cl, NO2, NH3, four types of ligands it is there. I mean, one ligand, two ligand, three types of ligands are there. And this one, this is chlorido. It is called as a nitrito Kn, and this is neutral ligand. Amine, this is negative ligand. This is negative ligand. This is neutral ligand. Then arranging the amine first, NH3 to be written as a first amine, and then now chlorido C, and then N should come nitrito Kn. So halogens, if it is a halogens, no need to enclose in a close bracket. So that is what I have written here. And then how to write K3 in a coordination entity, that is central metal atom, and here one ligand cyanido and another ligand is a nitrito. This, I mean, this is called NO. It is because it is the same number. I mean, Roman letter N and Roman letter O. It is called nitrosyl. So in this nitrosyl, it is N starts, it is cyanido C starts. So it is already correctly it is given, but cyanido to be written, carbon is a donor atom. So cyanido Kc, and it is called as a nitrosyl. So numeral prefixes to be indicated in the number of ligands. Let us see. The monodentate, if it is a 2 means di, 3 means tri, 4 means tetra, 5 penta, 6 means hexa. That means 2 times di, 3 times tri, 4 times tetra, 5 times penta, 6 times hexa. Here it is 5 times. It is called as a penta because it is a monodentate. Cyanido is a monodentate. And this is a nitrosyl. It is also monodentate. So now we'll see there is no need to indicate the number of the counter ions, no need to indicate at all. This K3, no need to say tripotassium and all. So we should say only potassium. K4 also we should say only potassium. So more than one ligands in case of bidentate and polydentate. In both the cases, if 2 comes, it is called bis. Is we should say. 3 means tris. 4 means tetrakis. 5 means pentakis. Like that we should say. So 2 is called bis, 3 is called tris, 4 is called tetrakis. For example, COEN, thrice enclosed in a closed bracket. This is called as a bidentate. So it is called 3 times it is called as a tris. So tris ethylene diamine, Gopal, Roman letter 3. It is in a cationic complex. So we should end it by the writing a ion. If no charge means no need to write ion, whether 3 minus or 3 plus, we should write it as only ion to be written. So here, tris ethylene diamine, Gopal, Roman letter 3 ion. Roman letter 3 is the oxidation state of central metal ion to be written in a closed bracket. Then here NiCl2 P PH3 2. So this is called as a triphenyl phosphine. Triphenyl phosphine is a polydentate, so it is called as a bis. So what first we should say? Cl should say first. So chlorido is a 2 times. So dichlorido, because it is monodentate, so dichlorido. If it is a polydentate, we should call it as a bis. 2 means bis, 3 means tris. So bis triphenyl phosphine. And nickel, valency of nickel is 2 plus 2. So write in a Roman letters enclosed in a closed bracket. Then oxidation central metal ion to be signed in a Roman numerals. Plus 2, many times I told you, write in Roman letter enclosed in a closed bracket. Plus 3, Roman letter 3 enclosed in a closed bracket. Plus 4, Roman letter 4 enclosed in a closed bracket. This is called square bracket. This is called a closed bracket. This is called as a closed bracket. Then another example, K3, Fe, Cn6. So counter ion is K3, so no neglect this number, only say potassium. potassium, and then naming from right to left within a square bracket. This is 6 times, so Xa. This is cyanido. Carbon is a donor atom, so we should write Kc. It is an anionic complex ended by 8 of the central metal ferrate. Roman letter 3 is the oxidation state. Mentioned in Roman letter enclosed in a closed bracket. And FeCO5, so carbonyl is the neutral ligand, so no charge of this. So the oxidation state of the central metal ion is zero oxidation state, we should mention. So for this is come from right to left, that is first ligand and then central metal. First number, that is penta. Next name of the ligand, carbonyl. Then central metal, it is called ion. Then oxidation state of central metal ion is zero, to be enclosed in a closed bracket. So pentacarbonyl ion, zero valency. So ending the names within when the complex is anionic complex, I mean the central metal atom should be ended by 8, I said. So for cationic complex and the neutral complex, no special ending. Only for anionic complex, there is an end of the central metal ion to be 8. So few examples. If it is aluminium is a central metal ion for anionic complex means aluminate, chromium, chromate, cobalt, cobaltate, copper, cuprate or cupirate. We can call both cuprate or cupirate. Manganese, manganate, nickel, nickelate, tungsten, tungstate, zinc, zincate, boron, borate, and chromium, chromate. Here in Latin words, that anionic, this full coordination is Latin and Greek words only is present. So for anionic complex, Latin name is some metals are commonly used as ion is called ferrate, copper is called cuprate, silver is called argentate, gold is called aurate, tin is called Sn stannate, lead, Pb is called plumbate. Once again, I'll say it should be ended with the 8 if it is an anionic complex. So iron is called as a ferrate, copper is called as a cuprate, silver is called argentate, gold is called aurate, tin is called stannate, lead is called plumbate. Then common multidentate, that is chelating ligands. Now we are going, let us see this chelating ligands. 1 minute please. Okay. Now let us see these examples and charges. So here the abbreviation ENOX glycinate, that is called ethylene diamine, is a neutral ligand, and oxalato and glycinato. These are called as a bidentate. Each single substance contain two donor atoms, and here also two donor atoms. Here two nitrogen is a donor atom, here two oxygen is a donor atom, here one nitrogen and oxygen is a donor atom. So they are called as a, all these three called as a bidentate. The common name for EN is ethylene diamine, for oxa, short form is oxa. It is called oxalato. Oxalate is a common name, and glycinate. So if it is an IUPAC name comes, E is replaced by O. So oxalato, glycinate, glycinato. And ethylene diamine IUPAC name is ethane hyphen 1,2 diamine. So ethylene diamine CH2 NH2 CH2 NH2, here the charge is 0. But here it is a COO minus, the charge is -2. Here CH2 NH2 COO minus is only 1, -1 charge. And for this diene, the short form of diene is writing as a tridentate. So in tridentate, that the example is diethylene triamine. The IUPAC name is 2,2 dash imino diethylamine. This is NH2, CH2, CH2, NH, CH2, CH2, NH2. No charge at all because only the donor atoms contains 3. 1, 2, 3. three atoms, so it is called as a three donor atoms, so it is called tridentate, but shortly we can call it as a diene because diethylene is called as a diene. So next abbreviation for a triene, short form is triene. It is a tetradentate. So triethylene tetraamine, same name also we can write triethylene tetraamine, also common name NH2 CH2 CH2 NH CH2 CH2 NH CH2 CH2 NH2. No charge at all, that is zero charge, EDTA. It is short form of writing hexadentate ethylene diamine tetraacetate. It should say in IUPAC acetato. Already I explained in brief, 2 2 dash comma 2 double dash comma 2 triple dash hyphen within a square bracket we should write a parental hydrocarbon ethane hyphen 1 comma 2 diaryl dinitrilo tetraacetato. This is the structure CH2CH2 N CH2COO minus CH2COO minus instead of 2 hydrogen this amine. Here this amine H2 instead of 2 hydrogen CH2COO minus CH2COO minus is substituted. Here 4 negative charges minus 4. By writing separately we can write minus 4, but in the formula if you want to write 4 minus is the correct procedure of writing. Thank you students.